Okay, number 12. A submarine at the surface of the ocean makes an emergency dive. Okay, here's my ocean. Here's my submarine. It's on the surface. I have no idea what a submarine looks like. But anyway, here's my submarine. Probably shouldn't have drawn it so far over. But anyway, okay, submarine at the surface of the ocean makes an emergency dive. It makes an angle of 21 degrees with the surface. Here is the surface. It's telling you this is one side of the angle. It's diving. It's going down. So it's diving like this. It's saying that this is 21 degrees, okay? It's making an emergency dive. It goes diagonally. They don't drop down like this. I don't think so. But anyway, 21 degrees to the surface. So there and there. Okay, and we're interested in finding horizontal and how deep. So vertical and horizontal. It goes 300 meters along its downward path. This might make you think this is down, but it's going along the path. This is the actual path of the submarine. So this is the part that's 300 meters. Down can mean diagonal. Down can mean vertical. Okay, but this is 300 meters here because we're talking about the downward path. This is the path that the submarine takes. Okay? All right, and we're interested in how deep it will be. So I think we call that X. I'm not sure. And the horizontal distance would be Y. How far over this way, how far down that way. So obviously we're thinking about trigonometry. Before we go anywhere, we need to label the sides. Here's my angle. Remember, if I'm here, this side is the hypotenuse. It's opposite the right angle. And the side facing the 21 is called the opposite. The side that's next to the 21 is the adjacent. Okay, let's see what I chose here. I chose to look at how deep. So we're doing the vertical change first. I hope I chose X for this, or else it's going to be confusing, but let's see. Okay, if we're finding how deep, we're going to do opposite, and we have the hypotenuse. Opposite hypotenuse is going to be sines, because we have OH. Sine of theta equals opposite over hypotenuse, and good, we went with X there. Sine of 21, 21's my theta. Okay, X is my opposite, and my hypotenuse is 300. Okay, I'm going to multiply both sides by 300 to get X by itself. Okay, and then I have X equals 300 sine 21, and we literally just type that in. Okay, 300 times the sine of 21, and it's about 107.51, and we're measuring it in meters. Okay, 107.51 meters. Okay, so that's the depth. Okay, and we're going to do a similar thing for the horizontal change, but we're going to use the adjacent with the hypotenuse. So this time AH can be cosines. Horizontal distance, the cosine of theta equals the adjacent over the hypotenuse. And we plug the values in. The cosine of theta, we know theta is 21. The adjacent we need to find, so we plug in a y, and that's 300. And it's the same thing. Multiply left and right by 300, cancel, cancel, and then we have y equals cosine of 21 times, 300 times the cosine of 21. So 300 times the cosine of 21, and there you have it, 280.07 meters. Not such a bad question after all.